Now let us define the inverse of secant x and okay, first of all, we know the domain of secant x. What is secant x? It is the reciprocal of cos x, 1 by cos x. So 1 by cos x. Is it defined to all values of x? No, it is not defined at x is equal to 2n plus 1 pi by 2. General solution of cos x is equal to 0. When cos x is equal to 0, then this 1 by cos x does not exist, and that means secant x function does not exist. So that 1 by cos x is not defined at x is equal to 2n plus 1 pi by 2 wherein belongs to z, set of integers. Therefore, the domain of secant x is equal to r minus 2n plus 1 pi by 2 such that n belongs to z, set of integers. Now, secant x, the domain of secant x is r minus of 2n plus 1 pi by 2. But what about the range? The range here, since cos x belongs to minus 1 to 1, then secant x does not belongs to minus 1 comma 1. That means secant x belongs to minus infinity to minus 1 closed union 1 to infinity. It is just like as cosecant x. So sin x also lies between minus 1 to 1, hence their reciprocal values does not belonging to the interval minus 1 to 1. Similarly, cos x also belongs to the same interval minus 1 to 1. Their reciprocal values does not belong to the same interval, hence cosecant x and secant x both are not in that interval minus 1 to 1. That's why both cosecant x and secant x have same range minus infinity to minus 1 union 1 to infinity. Now in this domain secant x, it is clearly not a 1-1 function. So that to make it 1-1 function, we have to restrict the domain to 0 to pi. If secant x is restricted from 0 to pi excluding pi by 2 to minus infinity to minus 1 union 1 to infinity. Now in that interval, yes, now the secant x is 1, 1 and onto. This is 1, 1 function as well as onto function. Therefore, 1, 1 onto. Hence, the inverse of secant x or arc secant x is defined from minus infinity minus 1 union 1 to infinity to 0 to pi excluding pi by 2. Therefore, here secant x is a bisection. Therefore, inverse of secant x denoted by secant inverse x, which is defined from minus infinity minus 1 union 1 to infinity to 0 to pi. So, minus pi by 2 excluding pi by 2. Now, in that interval, the secant inverse x is also bisection and it is the inverse of the given function. Now, above we have the graphs of secant x and secant inverse x. So, we know that secant x graph is like this. So, similarly, in the same way, just like as cosecant x, secant x values are also not belonging to the interval minus 1 to 1. So, that there is no graph between minus 1 to 1, and here at odd multiples of pi by 2, 2n plus 1 pi by 2 means odd multiples of pi by 2, secant x does not exist. So, that consider the vertical lines at that odd multiples of pi by 2, 3 pi by 2, 5 pi by 2, similarly minus pi by 2, minus 3 pi by 2, etc. Now, here in between minus pi by 2 to plus pi by 2, the secant x graph is like this, and between pi by 2 to 3 pi by 2, it is like this. So, as we take the values secant 0, 1, secant pi by 2 is tending to infinity, secant of minus pi by 2 also tending to infinity. Now, secant pi value minus 1 and secant pi is equal to minus 1, as secant values are tending to pi by 2, it goes to minus infinity, and as x value tending to 3 pi by 2, again the secant x values are also tends to minus infinity. Similarly, as from 3 pi by 2 to 2 pi, the graph is decreasing like that. Okay. Now this is the graph of secant x, you know. Now secant inverse x, the graph of the secant inverse x. So here the x values are minus 1 to 1. Here also there is no graph between minus 1 to 1. And see, suppose if secant pi is equal to minus 1, therefore pi is equal to secant inverse of minus 1. By the definition of the function, when f is a function defined from x to y, is a bisection, then for every y belongs to y, then there exists some x belongs to x such that f of x is equal to y implies and implied by x is equal to f inverse y. Now this is the definition of the inverse function. So according to that, secant pi is equal to minus 1, so pi is equal to secant inverse 1. Similarly, you can define all other values. You know, secant 0 is equal to 1, therefore 0 is equal to secant inverse 1. Secant inverse 1. So at 1, the secant inverse, with respect to secant inverse, the value is 0, and secant pi is equal to minus 1 means secant inverse of minus 1. At minus 1, the value, secant inverse value is pi. Now here secant 0 is equal to 1, 0 is equal to secant inverse 1. Similarly, we have secant pi is equal to minus 1, pi is equal to secant inverse of minus 1. So at x is equal to minus 1, the secant inverse value pi, as x values are tending to minus infinity, then the graph also tends to minus infinity, and here on right side, as x tends to plus infinity, then the graph is also tending to like this, minus infinity, and x values are tending to pi by 2, the graph tends to plus infinity. So according to the definition of secant inverse x, we can draw this graph like this. Now the definition of tan inverse x. You know, tan x is equal to sin x by cos x. Now this is defined if cos x not equals to 0. Okay, this tan x function is equal to sin x by cos x. This ratio defines when cos x value not equals to 0. That implies x not equal to 2n plus 1 pi by 2, where n belongs to z, set of integers. Therefore, the domain of tan x, is equal to, the domain of tan x is set of all real numbers except odd multiples of pi by 2, 2n plus 1 pi by 2, where n belongs to z. What is the range? The range is minus infinity to plus infinity. Therefore, here the tan x function defined from R 2n plus 1 pi by 2, n belongs to z, to set of real numbers is not a 1-1 function, because this is the total domain of the tan function. Therefore, on this domain, tan is not 1-1 function, since if any two elements are chosen from the domain x1, x2 such that tan x1 is equal to tan x2, then the x1, x2 need not be equal, so that it is not a 1-1 function. Now, to make it into 1-1 function, restrict the domain again. Now, the domain is to be considered as minus pi by 2, open, minus pi by 2 to pi by 2, okay, to R, set of real numbers. Look here, tan of minus pi by 2 to R. Is it 1-1 function? Now let us know the graph of tan x first of all. So here the graph of tan x. The tan function at pi by 2, 3 pi by 2, 5 pi by 2, similarly minus pi by 2, minus 3 pi by 2, at those values tan does not exist because they are all odd multiples of pi by 2s. So as tan x is equal to x tends to pi by 2, tan pi by 2 tends to infinity, and tan 0 0, as x tends to minus pi by 2, tan value tending to minus infinity. Similarly, between pi by 2 to 3 pi by 2, after pi by 2, tan is negative, so that the values are starts at minus infinite position, and at pi tan is 0, and when x value tending to 3 pi by 2, the tan values are tending to infinity. So that similarly after 3 pi by 2 to 2 pi, the graph is like this. So before minus pi to minus pi by 2, the graph is like this. So this is the graph of tan x in the interval minus pi by 2 to pi by 2. First of all, we have restricted the domain from minus pi by 2 pi by 2. You just confine the domain to minus pi by 2 pi by 2 only. Now look there, the graph is completely increasing. Say from minus pi by 2 to 0, it is increasing, 0 to pi by 2 also increasing, and no two values are having same images in this domain. So that this minus pi by 2 pi by 2 is called principal domain or principal branch of tan x. Now in this interval, it is clearly 1 1, and it gives all real numbers during this interval minus pi by 2 pi by 2. So that range is equal to R. Hence finally we can conclude that tan maps minus pi by 2 pi by 2 to R is 1 1 function and onto. Therefore, now we can define inverse of the function R2 minus pi by 2 pi by 2, known as inverse of tan, denoted by tan inverse. Therefore, tan inverse is defined from R2 minus pi by 2 pi by 2 is also 1 1 and onto bisection. So now this is the inverse of tan x, and the inverse of tan x, the graph of inverse of tan x or arctan is given here. Now here the domain is equal to R, set of real numbers from minus infinity to plus infinity. So here the graph according to the tan inverse x function, the graph is tan inverse 0 0 and tan inverse infinity. As x tends to infinity, then the tan inverse values are tending to pi by 2. As x tends to minus infinity, then tan inverse values are tending to minus pi by 2. So that again the graph of tan inverse x between minus pi between R. Now here tan inverse 0 is equal to 0 and tan inverse infinity is equal to tending to pi by 2. Tan inverse of minus infinity tends to minus pi by 2. Similarly, in the interval pi by 2 to 3 pi by 2 also the graph is like this. As tan x tending to infinity, tan inverse infinity tends to 3 pi by 2, and as x tends to minus infinity, tan inverse of minus infinity tends to pi by 2. So that the graph of tan inverse x during this interval R is again, so pi to 3 pi by 2. When we take the interval 3 pi by 2, 5 pi by 2, again it is like that, and if we take the negative values, now it is like that, minus pi by 2, minus 3 pi by 2 to minus pi by 2 in the same way as minus pi by 2 to pi by 2. So that is the graph of tan inverse x.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.